This is South West Mock 2026, Paper 1, E-Science for Intermediate to Ordinary Level. This question is also under Chemistry for Ordinary Level students. The question says, on which of the following components are elements classified into groups? A, number of protons. B, number of neutrons. C, number of shells. D, number of valence electrons. To understand what they're asking for, what do they mean by groups? Well, this is the periodic table, simplified version of it. For secondary school, you're expected to know and memorize the first 20 elements. I've taken my time to draw this very quickly, and I have arranged the elements into groups. Groups on the periodic table are the vertical columns into which the elements are arranged. We have groups that go from 1 to 8. 1, 2, 3, 4, 5, 6, 7, 8. Now we have what we call rows. The rows or the horizontals like this are called periods. So we have, this is period 1, this will be period 2, this will be period 3, and this will be period 4. So you have the columns of the groups and the periods, right? So now they're asking you that what did they use as a criteria to put all these elements here into group 1? What did they use as a criteria to put all these elements here into group 2? Because these here are in group 2, as you can see. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. Well, the very first option which they gave, the first option says number of protons. Well, what are number of protons? Number of protons are simply used to give us the identity of an element. If I wanted to identify each of these elements, I will add a number starting from hydrogen. I will begin from here with the number 1. So I'll put 1 here, 2 protons, 3, 4, 5 protons, 6 protons, 7, 8, 9, 10, 11, 12, 13, 14. So these are all these are the number of protons. I see how easy it is to assign the number of protons to the elements. So each element is identified by its number of protons. The number of protons are unique to each element. So they help us identify the elements, but they don't help us arrange the elements into groups. The next answer option which they gave was number of neutrons. Well, the number of neutrons are not used to arrange elements into groups because elements with different neutrons can still behave in the same way. Okay, so neutrons are really not part of chemical reactions. This table has elements that are arranged based on the way they behave in chemical reactions. And in chemical reactions, we talk about electrons, not neutrons. So neutrons don't really influence chemical reactions on this basic level. Now, so the next option which they give is number of shells. Well, elements are not arranged into groups based on number of shells, but they are arranged into periods based on number of shells. So all the elements in period 1 have 1 shell. All the elements in period 2 have 2 shells. All the elements in period 3 have 3 shells. For example, if I was to write the electronic configuration of sodium, sodium has 11 protons, 11 electrons also for a neutral sodium atom. So I will write that as 2 is to 8. That will be 8 plus 2, 10 electrons is to 1. So you can see that the first shell, called the K shell, or the shell n equals 1, takes 2 electrons. 2 electrons. The second shell, the shell n equals 2, or the L shell, will take 8 electrons. And the third shell, or the shell n equals 3, M shell, will take 1 electron. So you can see that sodium has 3 shells, and so it is in period 3. So shells are used to organize elements into periods, and the shells tell us how far electrons are from the nucleus. If I was to draw a model of the atom like this, if this was the nucleus here packed with protons, then this is the first shell. I could put 2 electrons here, and the next shell I will put a couple of electrons here. Remember that the next shell can take 8 electrons. So we have 2, 4, 6, 8. So the shells are simply telling us how far the electrons are from the nucleus. These electrons are closer to the nucleus than these ones. So these electrons are on shell 1, so they are closer than shell 2. So shell 2 are on a different energy level or on a further energy level from the nucleus. So, but shells do not tell us about reaction chemistry, or shells do not help us to group. Well, shells do tell us about reaction chemistry, but shells do not help us to group elements into groups. So what is the criteria therefore? The last option which they gave us is number of valence electrons. What are valence electrons? Well, valence electrons refer to the electrons in the outermost shell. So if I come back to the electronic configuration of sodium, which we used earlier, sodium with 11 electrons, we had 2 is to 8, that's 10 electrons, is to 1, that's 11. We can see that the last electron in the outermost shell is this one electron. That's the valence electron. Let's try to write the electronic configuration of another element like lithium. Lithium has three electrons, so I'll put lithium with its 3 protons or 3 electrons also here. And the first one will take 2, the first shell takes 2 electrons, and the last shell will have 1 electron. So you can see that lithium also has 1 valence electron or 1 electron in its outermost shell, just like sodium had 1 electron in its outermost shell. Let's try to write the configuration of potassium, sorry, this is potassium. So I'll say potassium will be 2 is to 8. So this we have 10 electrons. And if we add 8 here, we have 8 plus 8, that's 16 plus 2, 18. So we have 1 last electron to make 19. And we'll put that in the last shell. Again, potassium's valence electron is 1. Potassium has 1 electron in its outermost shell. So you can notice that all the elements here, look at all these elements that are in group 1, groups are columns. This is group 1. Lithium, sodium, potassium, they all have 1 electron in their outermost shell. So elements are placed in the same group based on the number of valence electrons they have, or the number of electrons in their outermost shell. And so the correct answer option here was number of valence electrons.